Good day, folks. In today's class, I'm going to continue talking about chapter number 4. Again, just wanted to tell you, if you understood the chapter number 4, you don't need to watch this video. You can skip this video. Now, in the last class, we talked about the coefficient of correlation. In today's class, we'll talk about the coefficient of regression and the linear equation. Just to give you guys one more time, a little bit of a brush up, coefficient of correlation helps us in finding the relationship between X and Y values. And by looking at this chart, we can always figure out what kind of a relation exists between X and Y values. Is it a strong positive correlation? Or shall I say perfect positive correlation, or a strong positive correlation, moderate to weak, depending upon the graph. You will be able to find out the what kind of a relation exists between X and Y values by finding out the R value, and that's what we did to find out the R value. Okay, we drawn the graph, and then we figured out the R square value. From there, we square root that value, we figured out the R value from there. All right, coming back to what is the topic for the day, that is a coefficient of regression. So regression helps us in finding out what percentage of value we can justify eh, based on the given question. So for example, in this particular question, if I go back into this question tells us that the monthly premium quoted by the insurance company for last 10 years, 100,000 critical illness policy, was collected from a sample of 12 adult female non-smokers between the age of 25 and 55. So this is the sample given to us. Plot the data, XY data, calculate the linear uh, correlation coefficient, blah blah, different things. Now if let's say if I was asked to find out the coefficient of regression in this case, so this is age given to me and then monthly premium. So I'm going to do the same thing. I will look at this data, I'll redraw everything. So look at this data, select everything, and then gonna click onto the insert, and then I will select this chart and press OK. I have this brand new chart in front of me, and then I can select the trend line, and on top of that I can select the R square value and the equation of the line. And these are the two things I have now. So R square value. So if I look at the R square value, that comes out to be 0.7389. First of all, R square value will always lie between 0 and 1. Again, I'll repeat it. You can note it down. R square value will lie between 0 and 1. R value lies between -1 and +1. That depends upon what kind of a slope you have. But R square value will always be positive. It will always be between 0 and 1. All right. Now, we figured out the R square value. Now we wanted to understand the meaning of this. The, let's look into this data. It tells us what is the relation between the age and the monthly premium paid. So based on this R square value, I can say, if I put it in percentage form, if I zoom it in, I can put it as 73.89. By multiplying it by 100, I can get 73.89, or I can say approximately 74% also. I will say that 74% of the monthly premium values in this given data can be justified based on the input data, which is the age in this case. So in short, it means that I can justify 74% of the values that they are related to the age. That more older you're gonna get, higher premium you have to pay. But rest of the 26% of the data points, so let me write it down also. So 74% approximately, I can justify that they are dependent upon age, that how much monthly premium you will pay. But remaining 26% of the data points, you cannot justify it based on the input values, which is age. They may depend upon some other factor, something like the person may be smoking, maybe person has other illness problems, other health issues, so there are other factors which we need to look into for justifying the remaining 26% of the values. So hopefully you were able to understand what is the meaning of R square. Now, the next thing we're going to learn is the equation of the line. Let me just sharpen up the pencil first of all. And yeah, so this is the equation. Now, in this equation, there are two things. One is this portion is called slope, and this is called y-intercept. And I wrote down the equation also, y equal to mx plus b or mx plus c, which means one and the same thing. Some people write it c, some people write it as b. M means slope. X is the x-intercept value. X value I can put it as. And y is the whatever VL, UE, whatever the y value you're gonna get from your work. Now, first of all, in your Breda, the equation can be written like b plus mx. So please make sure you don't confuse yourself. So they've written it other way around. So this one is mx plus b. So if you are asked to find out the slope value, so make sure slope value is always the whatever is written in front of x. Constant of x is slope. Well, I shouldn't use the word constant, but anyhow, whatever term which is written in front of x, that is slope. And b value is the y-intercept. Now, why we need to study this? This equation helps us in forecasting the values. For example, I'm going to look at this question down here. So this is a perfect example what I was talking about. Look at this equation that it is written as b plus mx, and b value in this case is minus 8.89. So hopefully you've been able to understand what I'm talking about so that you don't make mistake while doing these questions in exam. The relationship between the birth length in centimeter and the birth weight in kg of a sample of 50 newborn female babies yielded a correlation R value, which is given to us, and a linear equation of y equal to this. The babies all had length between 46.5 centimeter and 53 centimeter, and the weight is between 2.5 to 4.05 kg. Based on this estimate the birth weight of a newborn female baby with the birth length of 50.5 centimeters. So someone who's born with this much length, what will be the birth weight of that person or of that baby is? So in this question, I need to find out what is x value and what is y value. So birth length is on the x, and birth length given to me is 50.5 centimeter. So I'll write down the equation one more time. Y equal to minus 8.89 plus 0.243 x. And here in this, oh, okay, Control Z. I will put it as something caps lock X. I don't want to use any equation here. Oopsie. Okay, let me just write down the equation. Y equal to 0.8, well, not 0.8, sharpen up the pencil. So y equal to negative 8.89 plus 0.243x. X value is 50.5 centimeter. So I'll make sure I put it as 50.5 centimeter here. plus 0.243. I must make sure whatever dimension given here, I use the same dimension. Here it is said in centimeters. I must make sure this is also in centimeters. Otherwise, I need to convert them. Equal to negative 8.89. Once you're going to calculate this value, that's going to give you the uh, estimate the estimate birth length of a newborn female baby. So that will come out to be, let me just do some calculation, equal to negative 8.89 plus 0.243, multiply it with 50.5. That's gonna give you answer. That means approximately y value is this much kg, because y is a sample which is in kgs. Right, so hopefully you were able to understand. Sometimes in exam you may be given the y value. So something like you may be given the birth of a newborn baby is 3.3815 kg. Find out the estimate the birth length. So then in that case you will put this y value here, and then you have to find the x value, 8.89 plus 0.243 multiplied by x. And how you're going to calculate that? You're going to move this on the other side. 3.3815 plus 8.89 equal to 0.243x, and dividing both sides by 0.243, 0.243. So make sure you add these two terms first, then divide by this. That's going to give you the x value. All right. So hopefully you were able to understand what equation, what is the advantage of using the equation, okay, linear equation. So that's about it from my side for this chapter, and I'll see you with another video. Till then, goodbye.